Give you a tutorial on the application of Newton's law of motion. So here we have a static problem where the angles are not the same. There's two strings attached from a ceiling. They come together and there's a box suspended that has 4 kilograms mass. So notice that this angle between the ceiling and the string is 30 degrees. Then this angle between the ceiling and the string is 45 degrees. So what's the tension of those strings? So like what we all know, applying the first law of motion, we do know that the sum of all the forces acting along the x and y direction is 0. Since there is no external force acting on the object, it is in a static situation, so we now have to identify the sum of all the forces in both an x and y direction. So let's now draw the free body diagram. First, draw the tension downward, which is equal to the weight of the object times the gravity. Then the y component, the y positive component, then the tension on the left side, which is 30 degrees. So let's have this tension 1, which is angle theta degrees. So let's make it angle theta 1. So on the right side, let's make it the tension 2, which is the angle theta 2 with 45 degrees. So let's not forget to label the tension acting downward, which is the tension 3. Then this is tension 1 on the x direction. Notice that this angle theta is equal to 30 degrees and this angle theta must be 30 degrees as well because alternate interior angles are equal, which means this becomes the opposite of the angle. Then we have t1 times cosine theta 1. Then it's just the same as t2. This angle must be 45 degrees as well, since they are alternate interior angle. This leads to t2 times cosine theta 2. So let's proceed on the equation. So on the x direction, there is only two components, t1 on x negative direction and t2 on the x positive right direction. So for the first equation, t2 times cosine of theta 2 minus t1 cosine theta 1. Now on the second equation, we have two positive components, t1 times sine theta 1 plus t2 times sine theta 2 minus mass times gravity. So let's go ahead now on solving the first equation. So for us to get the tension 1, let's move this one on the side and eliminate 0, so we can have the answer on tension 1. So t1 times cosine theta 1 is equal to t2 cosine theta 2. So as you can see, the 0 is eliminated. Then t1 is equal to t2 times cosine theta 2 over cosine theta 1. So we now have t2 times cosine 45 degrees over cosine 30 degrees. So now let's compute cosine 45 degrees over cosine 30 degrees. So the answer would be 0.816 T2, since T2 is not yet known. So for the meantime, the value of T1 or the tension 1 is 0.816. Let's move on to the second equation. So as you can see, the value of T1 is 0.816 T2. So let's put that, then multiply to sine theta 1 plus T2 sine theta 2 minus mass times gravity. So there, let's substitute all the sine theta, so 0.816 T2 times sine 30 degrees plus T2 times sine 45 degrees minus 4 kilogram, which is the mass of the object, times 9.8 meter per second squared, which is the gravity. Then let's compute it now. Then we'll get 0.408 T2 plus 0.707 T2 minus the product of the mass times gravity, which is 39.6 Newton. Then let's add the like terms. Then we'll have 1.115 T2 minus 39.6 Newton. So now, since they are unlike terms, let's put them side by side. So 1.115 T2 is equal to 39.6 Newton. Then since T2 is what we're looking for, divide it to 1.115. Then we'll get T2 is equal to 35.52 Newton. So since T2 is already determined, so let's go back to our first equation, which is not yet completely solved. Then we'll have T1 is equal to 0.816 T2. Then substitute it to 0.816 times 35.52 Newton. Then we'll have the final answer for the first tension, or T1, which is 28.98 Newton. So here's the final answer. So let's go back to our diagram. So the T1 would be 28.98 Newton, and the tension 2 would be 35.52 Newton.